5 inventions the creators never lived to see. Number 1. The difference engine. Charles Babbage. During the Victorian era, all mathematical tables were calculated manually, a tedious process, with many errors slipping in. Charles Babbage, an English mathematician and philosopher, envisioned a machine able to perform all those calculations automatically, thus eliminating errors. Conceived as a digital device, it used toothed wheels to represent and carry over digits from 0 to 9. It was not only suited for solving complex mathematical problems, but it also had temporary data storage as well as the ability of printing the results onto soft metal. Funded with €1,500 by the British government, Babbage hired Joseph Clement, a skilled engineer, and began working on the engine. By 1833, Clement refused to work further due to payment disputes, and the government ceased funding the project after having spent more than €17,000. Babbage died in 1871, having lived his last years in bitterness for not seeing his work complete. In 1991, 120 years later, the London Science Museum finished constructing and put on display a fully functional difference engine using technology available back in the Victorian era. It has 4,000 parts and weighs 3 metric tons. Number 2. High-power pistol. John Browning. During the 1920s, the French military requested a handgun that should be compact, have an ammo capacity of at least 10 rounds, could be easily assembled and disassembled, and could be produced at a low cost. John Browning, a legend among gun designers and salesmen, filed a patent in 1923. A thumb safety and external hammer were also incorporated in the design. Browning died in 1926 of heart failure, and the design was handed to and perfected by the Belgian Défense, finally introducing the gun in 1935. Although not adopted by the French army at the time, the high power is one of the most recognizable, widely used and most heavily sought firearms by collectors. Many conflicts in history had both sides using it due to its reliability and power. For its size, it is still manufactured today in Japan. Number 3. Pendulum clock. Galileo Galilei. When he was not being bullied by the Inquisition, Galileo observed and recorded physical phenomena. One of them was the back and forth motion of a suspended weight. The physics behind pendulum motion is no small deal. Its study paved the way for an entire branch of physics, namely the harmonic oscillators, a model that has helped represent and explain problems ranging from planetary motion to quantum mechanics. Galileo was the first to notice that, contrary to common intuition, the period of swing of a pendulum is independent of its swinging arc. In 1641, Galileo was 77 years old and blind. He had fully described the inner works of a pendulum clock, and San Vincenzo tried to make one without success. Galileo died in early 1642, leaving a lot of finely formulated physical theories to future scientists. It was in 1656, 14 years later, that the Dutch astronomer and physicist Christian Huygens built the world's first pendulum clock. Number 4. Automatic computing engine. Alan Turing. By the time World War II had ended, building a computer was entirely possible. Anyone with $500,000 and a really big room could have one. What was missing from the greater picture was a general-purpose computer. Existing models were very limited in what they could do. They could very specific tasks and nothing more. It was no wonder that the mathematical genius Alan Turing was summoned to build the very first electronic stored program general-purpose digital computer. In 1946, he presented his design to the UK National Physical Laboratory. Work began in 1947. ACE operated nothing like modern systems do, as its logic resembled more biological neuron functions rather than the Boolean logic all modern computers are based on. Turing stayed a few months on the project, leaving NPL technicians baffled about how to carry on. The pilot model, finished in 1950, was pretty fast for the time, though not exactly what Turing had envisioned. Turing died of cyanide poisoning in 1954, and the first full-scale ACE model was completed in 1957. Number 5. Omnia, the Airship. Enrico Forlanini. There was a time where airships were considered a good idea for passenger transport. After the Great War, Italian inventor and aeronautical pioneer Enrico Forlanini sought to put into air traffic a new airship type with unprecedented maneuverability. In 1930 he presented the design of Omnia, a 56-meter-long dirigible with 4 cubic meters capacity. What made it special, aside from Forlanini's already established expertise, was the addition of jet propulsion to the classic engine and propeller scheme. High-pressure air jets installed at the ship's bow and stern offered the ship unbelievable for the time maneuvering speed both on ground and in the air. Forlanini died in 1930 before the ship was completed, and aside for a test flight it never entered mass production. Its innovative design, however, became a point of reference and helped study and develop auxiliary thrust technology in aircraft. Subscribe and like.